Hello, boys and girls and Cougar parents. Let's take a second try at Dr. Dissection. And remember, if you don't like the metaphor and you can just go right to the inverse operations, that's fine. But tonight, though, we're going to make the difficulty a little harder. This time, our two-step and multi-step equations will include rational numbers. Yes, fractions, and decimals. So now our inverse operations will have to deal with fractions and inverse operations. Let's take a look at the assignment and give a few a try. See, we've got 3 halves x plus 1/5 is equal to 3/4. Can we clean up our patient at all? No, I don't see any common terms to combine. I don't see any distribution to do, so cleaning up, is not applicable. And then let's diagnose our patient. We can clearly see that it is being multiplied by 3 halves. And we can also see that there's something being added to it, and it's 1/5. And according to our permutation list, we need to always take care of whatever's being added or subtracted on the variable side first. So we'll have to deal with this injury first, and our second injury will be the multiplication fracture that we have. Okay, our prescribed treatments, how do we get rid of adding 1/5? We have to subtract 1/5. And how do we get rid of multiplying by 3 halves? And remember, we just want to change it to 1. We don't want it to be 0. We just want to change this to a factor of 1. So we would just multiply it by its reciprocal. And the reciprocal of 3 halves is 2/3. So we multiply it by 2/3. Okay, let's dive into this. Let's first subtract 1/5. We'll subtract this side by 1/5, and we'll subtract this side by 1/5. Okay, this will cancel each other out. I'll bring down 3 halves of an x. And over here, I can't subtract 1/5 from 3/4. They do not have a common denominator, so let's find an equivalent fraction. I know a common factor, or I should say a common multiple of 4 and 5, the lowest common factor is going to be 20. So if I change this to 20ths, I'm kicking this up 5 times. So I need to do the same thing to this. 4 times 5 is 20, and 3 times 5 is 15. I also need to make this in terms of 20ths. That is a 20. Okay, and I know 5 times 4 is 20, so I need to also multiply this by 4. There we have it. And when I subtract, I'm going to get 11/20ths. Okay, now that's taken care of. Now my next operation is multiply it by its reciprocal, which is 2/3. And what I do to one side, I need to do to the other side. Okay, they cancel each other out. I'm left with 1x is equal to, and I can simplify here. 2 goes into 2 once, and 2 goes into 20 10 times. I multiply straight through. I get 11. 10 times 3 is 30. 11/30ths, and I can't reduce that. Let's take a look at our fourth problem, where we have 1/2 times the difference of 4 and k, which is equal to 2/5. Can we clean this up? Absolutely. I've got some distributing to do. So I'm going to distribute. I'm going to distribute the 1/2 to both of the terms inside the parentheses. And 1/2 times 4 is 2 minus 1/2 of k, which is equal to 2/5. Okay, I need to diagnose what's happening to my variable k. It's being multiplied by a -1/2, and it's also being added to, being added by 2. Okay, this would be my first injury to treat, anything that's being added or subtracted to the variable, and then my second injury that I need to treat is anything being multiplied or divided by. Okay, my treatments for these injuries, the inverse operation of adding 2 is subtracting 2. And the inverse operation of multiplying something by a -1/2 is the same thing as dividing by a -1/2, which is really multiplying by its inverse. Okay, remember when we multiply by its reciprocal, we always get 1. So it's going to be a -2/1. or 2. Well, let's do our first operation, our first treatment first. We have to subtract by 2, so I subtract by 2 here, and I subtract by 2 over here. Okay, let me back up the bus here a moment. Okay, I subtract by 2 over here, and I'm going to subtract by 10 fifths, okay? I'm going to jump right to it. I know that 10 fifths is 2, okay, because 5 will go into 10 2 times, okay? And the reason why I did that right off the bat was I want to have the same denominator. Okay, I can subtract 2 fifths from 10 fifths, or I should say the other way around. I can subtract 10 fifths from 2 fifths. And let's take care of that. First of all, the 2's cancel out over here. I bring down my negative 1/2 k, which is equal to, if I take 10 fifths away from 2 fifths, I'm left with a negative 8 fifths. Okay, now I need to multiply by the reciprocal of negative 1/2, which is a negative 2 over 1. So I multiply this by a negative 2 over 1, and I do the same thing over here, multiply it by negative 2 over 1. These cancel each other out, and I'm left with k is equal to a negative 8 times a negative 2, which is a positive 16 over 5 times 1, which is 5. 16 fifths. You can change that to a mixed number if you want to, but that's good enough. And we have another healthy, happy patient. Okay, let's do a little dissection here. Here comes a patient that's really messed up. And we need to, wow, I think we got a patient here that's in pieces because I have a variable on both sides. Okay, this challenge problem is a little tricky, but we can handle it. Okay, the goal is to isolate the variable, and right now we have the variable on both sides. Well, we need to get it on one side. So what I'm going to do is I'm going to get rid of the half of a over here by adding 1/2 a over here. And what I do to one side of the equation, I need to do the same over here. Okay. Now this negative 1/2 a will be canceled out by my positive 1/2 a, and then I bring down 5/6. Now if I have 1 whole a and I add 1/2 an a, altogether I know I have 3/2 a plus 3/4. Okay, now I can begin to isolate the variable. I only have the variable on one side. I need to perform my inverse operations. Okay, I can see that 3/2 is being multiplied by a, and I also see that 3/4 is being added to the a side as well, the variable side. Well, I'm going to take care of the inverse operation of anything being added or subtracted, so I'm going to subtract 3/4 from this side, and I'll also subtract 3/4 from this side. Okay, that will cancel this out. I bring this down, and I will get 3/2 a is equal. Okay, now we run into some difficulty here with our denominators aren't the same, so we need to find our least common multiple, our least common denominator, which in this case is going to be 12. So I'm going to change this. 12 is the least common multiple between 6 and 4. Well, in order to go from 6 to 12, I'm multiplying it by 2. What I do to my denominator, I need to do my numerator, so this is going to be 10/12. Okay, and then if I increase this to 12, I'm really 4 times 3 gives me 12, so I need to make it 3 times 3, which is 9. Okay, now I can subtract 9/12 from 10/12, and this will give me 1/12. Okay, I gotta slide this guy up here a little bit. Okay, now I'm down to a one-step equation. What is the inverse of multiplying something by 3/2? Well, it would be either dividing it by 3/2, which is really the same thing as multiplying it by its reciprocal, okay? Because we're going to end up getting 2 times 3, which is 6, over 3 times 2, which is 6, and 6 over 6 is 1. They cancel each other out. I've got a. Whoops. What I do to one side of the equation, I need to do to the other. So I need to multiply this also by 2/3. And when I do that, I can simplify. First of all, 2 goes into 2. 1 times 2 goes into 12. 6 times. When I multiply through, I'm going to get 1/18. There's another happy, healthy patient. Let's take a look at our problem. Can we clean this guy up at all? No, there's nothing to simplify. So this is not, did it again. Okay, so cleaning up is not applicable. Let's diagnose then our injuries. We see that we are multiplying our variable x by 5/10, and I'm also adding 8 7/10. We need to take care of the adding injury first, then we'll take care of the multiplication injury second. We go in the inverse order of operations, we go backwards when we're solving for a variable. And what's our prescription for adding 8 7/10? It's none other than subtracting 8 7/10. And then our second treatment, well, what's the inverse of multiplying something by 5/10? It would be dividing it by 5/10. Let's first subtract 8.7 from both sides. That's our first operation. When we do that, this cancels out. I bring down my 5/10 of an x, and over here I have to do some regrouping. 5 minus 0 is 5. 3 minus 7 can't do that. I have to regroup. Okay, 13 minus 7 is 6. 11 minus 8 is 3. So I took care of my first operation. Now my second inverse operation is going to be divide by 5/10. So I divide both sides by 5/10. I can clearly see that that's going to cancel each other out. I'm left with x is equal to 3 65/100 divided by 5/10. Well, I can't have a decimal out here. I need to move my decimal point over 1 here. I need to do the same thing here. 5 will go into 36 7 times, which is 35. I subtract. I get 1. I bring down my 5. 5 will go into 15 3 times. So my answer is 7 3/10. That is my final operation, and my patient will live. Well, hopefully, boys and girls, that was more fun than a barrel of monkeys. And if it wasn't, hopefully you learned a few things. And if you have questions, please bring them to class tomorrow. I'm a good math teacher. I'm just a lousy mind reader. I'll see you tomorrow. Bye-bye.